everyone. We're so excited to be here today to talk to you about Kotlin and functional programming, two of our favorite things. We're going to dive into how you can make your Kotlin code more functional and hear about why we love it so much. So I'm Katie Levy. I'm a software engineer at Amazon, working in the Amazon Fashion org, working on backend services.
And I'm Shelby, and I'm a software engineer working at Twitter, also working on backend services on the search infrastructure team.
So our agenda today is just to talk first about what even is functional programming. Then we'll dive into how you can make your Kotlin code more functional. And lastly, more resources so you can learn even more.
So some specific aspects of functional programming that we found Kotlin really helped us teach were treating your code like mathematical equations. So with the same input, you always have the same output, composing smaller functions into larger functions, avoiding shared state, mutable data, and side effects. It's really good for multi-threaded support. And the more immutable data you have, the easier it is to test. And so functional programming is a lot of different things, but we wanted to tell you here today that you don't need to do all these things at once. You can break it down and do it step by step. So we'll show you how to get started today.
So a really big concept in functional programming is pure functions. So right on the left, we have a function that has an input and an output. And then on the right, we have something that's more like a procedure that has an input, some side effects that are going on that might be changing some shared mutated state in the application, and then an output. So we really want to focus on the left side, where we only have an input and an output and no shared mutated state, and where the same input will always give you the same output. So this is very much like a mathematical equation, and we can combine these functions together, these pure functions together, to compose our application.
So why do we want to use these functional programming concepts? It really enhances the readability of your code. It makes it easier for asynchronous programming. So when you're using multiple threads, it prevents memory leaks. It's much easier to debug and test because all of your logic is very isolated. And so you're not referencing a lot of external variables, and all of your key inputs are being sent into your tests, and so it's very straightforward. Also, adding new features should be really easy, so it makes it really simple to maintain your code, and also testing and debugging is very straightforward.
So what does this all have to do with Kotlin? So we're talking about functional programming. Why is Kotlin in the picture? We love Kotlin for various reasons. These are some of them. It's concise, safe, interoperable, tool-friendly, but we also found it really easy to do functional programming in Kotlin. It was almost like, the language writers wanted you to do functional programming as you're writing Kotlin, and it then allowed us to kind of teach more people how to use functional programming style as they were learning Kotlin or writing code in Kotlin. So we'll talk more about like specific examples, but it is key to note that Kotlin is not a pure functional programming language like Haskell is and some other languages, but you can introduce a lot of functional programming styles into your Kotlin code.
So how are you going to actually make your code more functional? These are some specific ways that you can get started, and we'll dive into them later in the talk, but built-in functions on collections. So that's like map, filter, flat map, immutable variables and immutable collections, pure functions with no side effects, and then single expression functions.
So a big aspect of Kotlin is that it has Lambda support, and in Kotlin, functions are first-class citizens of the language. That means that functions can be stored in variables, they can be used as arguments for other functions, and they can be returned from functions. This is really important to be able to kind of compose these different functions, pass them around, use them to make our code more functional. And then on top of that, Kotlin has in the collections in the standard library a lot of functions to kind of encourage you to do functional programming with things like map, filter, fold, flat map on top of the collections.
So let's dive into the code and show you what you can start using, which is Kotlin Map, which Katie just talked about. We have here on the left an example of Java map. So you can still do this in Java, but you can see it's a lot more verbose. We have to use .stream and .collect at the end. So let's focus on the right on the Kotlin version, where we have a number list defined, which is a list of integers, 1, 2, 3, 4. And we're returning number list .map, which is going to iterate over every item in the list. And then we get to use this keyword it to represent each item. And we're saying add 5 to each item in the list. It's super simple to do and straightforward. And we started converting all of our for loops that we had in our code to use map to make sure we're not mutating. And we're always returning a new list as a response. Similarly, we have Kotlin filter, where we are using that same keyword it, and we're going to define some sort of condition to say what we want to filter. In this case, if each item is greater than 2, we're going to keep it in the new list that's returned.
And then lastly, we have flat map, where we have Java code is pretty verbose. On the Kotlin side, it's a little more clean and easy to read, but we have a list of lists inside, specifically just 2 lists inside of this other list. And we want to flat map over that list of lists to add 5 to every element in the inner list. It's much easier to just do flat map. We also have the inline function on the flat map in there. So it's a lot more concise, a lot more easy to read.
So you can also define variables in an immutable way using val. And so if you try to mutate it when defining a variable with val, it will be a compilation error instead of a runtime error, which is really helpful. You can also still define them as mutable if you want, if you use the keyword bar.
And similarly with immutable collections, the default list of creates an immutable list. So if you want a mutable list, you explicitly have to say mutable list of to kind of encourage developers to use immutable lists more often than not.
So another way Kotlin encourages immutability is expressions, not statements. So we've been talking about making our code look like mathematical equations and avoiding mutation, and expressions is a way to do this. So here we have a function foo that takes in an integer and returns a string. Then we're using this when expression that's defining each case for different integers that are sent in, and then we have an else case as well. And the awesome part about this is that if we change any of these strings, the 1, 2, or the I don't know string, if we change them to a different type, we'll get a compilation error instead of a runtime error. And also this encourages us to not have large blocks of code in between each logic check that's mutating code. It looks very simple and it will always be the same type returned in each check.
And then here we have single expression functions. We can just put one line of code that has all of our logic. We don't need the curly braces and the function block. This makes it really easy to make smaller functions that we can then combine together to compose our logic. So functional programming really encourages small functions you combine together. Single expression functions make that so easy to do. So how can we make your code more functional? We kind of looked at built-in functions on the collections, things like map, flat map, filter. There's so many other ones. These are all great to use and encourage functional programming styles. We also have immutable variables, so using val as much as you can instead of var. And then having pure functions that don't mutate state and have no side effects. And then lastly, single expression functions, where you're composing the functions together and not mutating state again.
Awesome. So we know that this was a really quick lightning talk, but we wanted to just show you how you could get started today using more functional programming in Kotlin. If you want to dive in and learn more, we have tons of other content you can look at. We were recently on the Lambda Show podcast where we dive into more ways that we learned functional programming from the beginning. We also have our favorite book, Functional Programming in Java, where we took all the exercises in Java and converted them to Kotlin. But awesome that this summer there's a functional programming in Kotlin book coming out. So we're definitely going to check that out. And recently we also spoke on the Kotlin Belfast user group about the best of both worlds and dive into how we use Arrow with our Kotlin to make our code even more functional. But we want you to reach out to us on Twitter if you have any questions or comments. Unfortunately, we don't have time today to answer, but message us and tag us, and we would love to start the conversation there. So thank you so much, everyone.
Thank you.